Hello, in this video we're looking at normal distribution again, and this is part B where we're going to use our calculators, graphic calculators, to work out the probabilities and percentages with our normal curves. This is an example of a problem. The weights of Year 9 students are normally distributed. So when it says normally distributed, that means that we can use the bell-shaped curve, and the mean is 50 kilograms, the standard deviation is 6 kilograms. It does pay to have a highlighter when you're doing these problems to highlight the important parts. Always draw a little sketch so that you know, have an idea of the kind of values you're looking at. So here's my 50 in the middle, my mean is 50. My standard deviation is 6, and I'm going to draw 3 sections that side and 3 sections that side. And I know that this would be 56 here. This would be 6 less. My standard deviation is 6 kilos. Each of these sections is 6 kilos wide. And so this would be 44, wouldn't it? And 6 makes 50. Now, I want to know the probability that a student weighs no more than 59, but 59 kilos falls in a section part way through here. And if they weigh no more than that, it must be, they could be anything less than 59. So it could be any of this area that I'm looking at, the red shaded area. So, and this point here is 59. When we're using our calculators and we're wanting to find the shaded area, we need to know what's the lowest number and what's the highest number. So we have a lower value and a higher value. And my higher value is 59 here. My lower, this actually goes to infinity down this end, but the calculator, I can't put in infinity. So at the lowest end down here, I'll put in negative 9999. If it was the right-hand end, I'd put in positive 999 in my calculator. So with your calculator, go to menu and then stats. Mine's number 2, stats. And then at the bottom of your along the bottom of the screen, you'll see DIST for distribution, which is my F5 key. And then my F1 key above that is normal, and I press normal. And then above my F2 key, I have NCD, which is what I'm looking for. And then I either can choose at the bottom of the screen, F1 is list. If your data is in a list and you put it in your calculator, you can use that. In this case, we are just given a variable, so I'm going to push F2 is what we normally use. F2, and my data is a variable. Now lower, I've got my lower, I'm going to use the arrow key, go down and put in negative 9999. My upper is the upper value of the shaded area is 59, so do execute after that, then 59, execute, and then the S, Greek S, sigma, is the standard deviation, which is 6, execute, and my mean is 50, and the mean is the Greek M. And then I can see that my probability equals 0.93. 9331, and that would be about right, 93%. I've got all of the 50% plus some more here, so that sounds about right. Now you must check, this time they've asked for the probability, but they may ask for a percentage, so you need to change that to 93%. Now the second part of the question, find the expected number of students out of a class of 50 that would weigh more than 65 kilos. So again, we draw the graph. Here the histogram, bell curve, 50, and I'm going to go 3 here. I'm looking at the upper end, 50, I go up in sixes, so that would be 56, 62, and 68. Okay, so I'm looking for the expected number of students that would weigh more than 65. So I want to know this percentage here. So my lower is 65 and my upper is going to be infinity up here, so 9999. Again, my standard deviation is 6 and my mean is 50. And I'm going to put that in the calculator. Now let's go exit and arrow key up. So I can put my lower is 65, my upper is 9999, same standard deviation and mean, and then I get a probability is 6.2 times 10 to the negative 3. So that's 0.0062. 10 to the negative 3 means I move that decimal back 3, 0 and a 0, 0.0062. Out of a class of 50, I'm going to multiply that by 50 to get how many students. I'm not sure if it would be even one student. Of course, on your calculator, you've got to go back in your menu to the normal number and 1. 0.0062 times 50 is only 0.31. So you would hardly expect any students out of a class of 50. Out of a class of 150, you may expect maybe one student. Okay. Example here. The length of leaves on a eucalyptus tree are normally distributed with a mean of 12. Draw my curve. My mean is 12. And a standard deviation of 3. Find the probability that a leaf is longer than 14.5. So 12, there's 15 as the first standard deviation. But I want 14.5. Now if it's going to be longer than that, it'll be in this shaded black area. So my lower is 14.5 and my upper is infinity to the right hand end. So we go back, my standard deviation is 3 and my mean is 12. Exit 2. Okay. Now, sorry, my lower is 14.5 and my upper is 9. The standard deviation is 3 and the upper is 12. And so my probability, am I working out? You can check it with yours, 0.2. Find the probability that a leaf is between 10 and 14 centimetres. So again, if you did a curve, if your mean is 12, between 10 and 14, you want that shaded area. So lower is going to be 10, upper is going to be 14. And you can put that in your calculators and work it out. The last one, out of 1,000 leaves, how many would you expect to be less than 9 centimetres? So my curve is like this. My mean is 12. So this is 9 here. So my lower is negative 9999. My upper is 12. Sorry, my upper is 9. And my probability, so that's actually 9. Probability is 0.158. And if there's 1,000 leaves times 1,000, 0.158 times 1,000 is going to be about 158 leaves. Okay, there are lots of these problems in your books. Let's just look at one quickly here that you've got to be careful. When I'm doing this, this is the weight of baby girls in New Zealand. The mean weight here, the mean is 2.6 kilos, but the standard deviation is 300 grams. So I'm going to change this to either change the grams to kilos, 0.3 kilos, that might be easier, 0.3 kilograms I'll use as my standard deviation. So this is 2.6. What percentage of baby girls weigh under 3.2 kilos? So if my 3.2 is somewhere here, I want to know what percentage weigh under 3.2 kilos. So my upper is 3.2, my lower is negative 999, and they want a percentage, so make sure your answers is a percentage. If 300 girls are born this month, how many would weigh less than 1 kilo? So on my graph, which area am I shading? There's my 2.6. 1 kilo is probably down here. How many girls weigh less than 1 kilo? So that's just this area here. Upper is 1 kilo. Lower is negative 999. And my standard deviation is 0.3. And then when I find my probability, I'm going to my probability multiply it by 300, and that will give me the number of girls and rounded to the nearest whole number. Okay. Right. So we'll go in the next video, I'll do another video on inverse normal problems.